Given that in a series of pattern 1 requires 6 counters, pattern 2 requires 10 counters, and pattern 3 requires 14 counters, and so on. Pattern 1 requires 6 counters and 2 10 and third 14. Given that the number of counters needed to make pattern nth pattern is an plus 2. Find the value of a. The number of counters for the nth pattern is an plus 2. Now if you look the pattern of this sequence, you can observe that just by adding 4 in the previous term, we get the next term. So this is called first difference. If first difference is constant, this sequence is called arithmetic sequence. To find the nth term of the arithmetic sequence, we just multiply n with this first difference. Therefore, it will be 4n. Now we will verify. If we put this one in this, it will be 4 into 1, 4, but it is 6, which is 2 more than this 4. Now plug this 2 here, 4 2 is 8, but this is 10, that is 2 more than this. Plug this 3 here, 4 3 is 12, but it is 14, 2 more than 12. So the final arithmetic sequence, the nth term of this sequence will be 4n plus 2. Now verify that. If you put 1 here, 4 into 1 4, 4 plus 2 6. The first term is 6. Now plug 2, 4 into 2 8, 8 plus 2 is 10, it is 10. 3, 4 3 is 12, 12 plus 2 14. So this is correct nth term of the sequence. So if we compare this with this, so A is 4. Mary has 500 counters. She uses as many of these counters as she can to make a pattern. Given that this pattern is called M, find the value of M and how many counters are not used. Suppose, no, look the sequence here. If we have 14 counters, so how many pattern we can form? We can form 3 pattern. Let's verify this. So using this formula, so if we have 14 pattern, so 14 equal to 4n plus 2, and after solving this, this is the third pattern. If we have 10 counters, if we plug the values here, 10 equal to 4n plus 2, and solving this equation, it will be the second pattern number. Now we have 500 counters. This sequence is counters, and these term numbers are basically pattern numbers. Now we have 500 counters. So let's see which pattern number it is. And according to question, this pattern number will be M. After simplification, so we will have, if we have 500 counters, so they will be used fully in 124 patterns, and we have left some counters, but we cannot form a full pattern, that is 125th pattern. 125th pattern cannot be completed because we have not sufficient counters. We can complete just 124th pattern. Therefore, with the help of 500 pattern, we can create just complete 124 pattern, and that pattern number is called M according to the question. So for pattern number 124th, that is called M, pattern M, it will occupy 124. Now plug 124 in this formula. So the pattern number M will occupy, that is 124th number pattern will occupy 498 counters. But we have 500 counters, so 2 counters will left.